Continuing our analysis of is a coin fair when we flip it. Last class we tossed a coin 30 times and tried to figure out how many it would take for us to think it was unfair. We made a graph of all of our data. I had my class do it. I actually have a little bit different data for them that I'm going to show you in a bit. We talked about the mean and how to find the mean, taking the number of trials times the proportion of times that we expect it to be heads. So that was 30 times 0.5 and got us 15. Found the standard deviation, which is the square root of n times p times 1 minus p, and found that that was about 2.74. That tells us that the number of heads will typically vary from the mean of 15 by about 2.74 heads. We also checked our large counts to make sure that we can assume that this was normal by taking n times p and finding the number of heads we expect to be 15 and found that that was greater than or equal to 10, so that checked out. And then n times 1 minus p to find the number of tails that we expect, and that was 15 also. And we found that that was greater than or equal to 10. So that allowed us to assume that our sampling distribution is normal, and then we could apply this to it as well. So our little change here from what we did, we'll just fill in what we had here. We had 15. Let me make this a little bit bigger for y'all. So we had 15 here. Let's change the color, make it a little bit bigger. 15 for the mean. A little bit bigger there. So 15 for the mean, and then our standard deviation was 2.74. And then what we did was we had go Amy. We filled out a Google form and we got the number of heads flipped 40 times in my class. We had 10 people do it 4 times each. And we're going to go to statlet.com. Oh, go away. What are you doing? And we're going to go one quantitative variable, and we want to graph this. So number of times a penny flipped 30 times came up heads. So we can just paste our data, begin analysis, and we get our dot plot there. Kind of normal. I'm hoping my next class today will actually help get us even closer to normal there. I'm going to capture that region and input that into our notes here. So you should have access to this data. If you don't, you can email your teacher and they can let you have that data too. So today, instead of creating this dot plot that we had with number of heads, we want to create a dot plot showing the proportion. So that's our new thing today, is we're changing from number of heads, our count, to simply a proportion of the flips that were heads. So we're going to change the number of heads above into proportion of heads. So if I had, let's say I had 15 heads here, then to figure out the percentage of heads, I would just take 15 and divide by the total, which was 30, and that would give us about 0.5. If I had, let's say, 17 heads, I would divide it by 30, and that would give me 17 divided by 30, whatever that is. I'm going to round it to 2 decimal places, and that's going to be 0.57. Make sure you can see that, and so on and so forth. So what we're going to do here is to change from number of heads to proportion of heads. We're going to divide number of heads divided by the number of trials, which would be n, which would be 30. So what we're going to do is we're just going to go to our table of our data, and we're just going to divide all our values by 30. So on my spreadsheet, I made a second page here. I just duplicated my data over, and I said that my n was 30, and I wanted to, let me blow this up a little bit for you guys. And to find the sample proportion, I took C3, which was how many times I flipped the coin and got heads out of 30, and divided that by 30. And that gave me my proportion here, and I kind of minimize it to 2 decimal places there. So I'm going to go grab all that data. Oops. I'm going to copy all that data. I'm going to go back to my stats medic. I'm going to, let's just reset everything real quick. So we want the proportion of heads out of 30 flips, 30 coin flips. I'm going to paste my data there. Begin analysis. and we're going to analyze this graph. So I'm going to copy it. I'm going to put it right next to my other graph, and we kind of want to analyze it a little bit. So back to our notes, I'm just going to paste it. And then we want to analyze this. So how did it change? How did it stay the same? So what's different about it? What's different is instead of going from 8 to 26, we go from below 0.3 to above 0.85. So our scale has changed. So let's shut that down. So what's changed? The scale on the x-axis changed. And how did it stay the same? Well, you can see the general shape is identical. So we start with the few off to the left, the one all the way to the right, the peak is in the same spot, everything is identical, the shape is identical. Shape is stayed the same. We can also check our large counts again, and that should be the same. We should have n times p is greater than or equal to 10, and we should have n times 1 minus p is still going to be greater than or equal to 10 as well. This will give us the 15, 15 as well. So that helps us check to make sure data is normal. So our shape stayed the same. It was approximately normal, approximately symmetric. I'm hoping with more data today, it looks even better. It's a little fleshed out a little bit better. I do want to mark down here that this now is our sampling distribution of our sample proportions. And we're going to call that p hat, which is a p with a little crooked hat over it that I'm going to draw in, p hat. So finally, to wrap up this page, we want to talk about the mean and standard deviation of this sample proportion distribution. So let's think about how we change the number of heads into percent of heads. So what we did was we divided the number of heads by the number of trials by 30. We just took all those numbers, divided them by 30. So we're going to do the same thing with the mean and the standard deviation. So our mean, I'm going to use the equation editor here and make sure it's big so you guys can see it. So our mean, our mu, which, those aren't mu or anything. What are you doing? So our, oh fun, it was putting stuff in there. So our mean, mu, is going to be equal to 15 divided by 30, which gets us 0.5. So we expect to get 50% heads, which makes sense. This should be what we're expecting. Our standard deviation, sigma, was 2.74, and we're going to divide that by 30. And we should expect to get 0.091, let's say. So all we did to these values, the mean and the standard deviation, was just divided by n. So we can write that down as a general formula here. So we need our mu, so the mean, and we want to go lower, we want to go below, of p hat is equal, oh, that didn't work. Still not working. I don't know what's going on there. There we go. Our mu of p, and I'm going to put a little hat there to show that it's a sample proportion, is going to be equal to, well, our mean was n times p, and we divided n there. So if you remember your algebra, when we have n times p on the top and n on the bottom, I'll clean that up so that n, there's no parentheses there because we don't need parentheses there. What's going to happen is we got n on top and on bottom. Those are going to cancel each other out, and we're just going to be left with p, which is what happened. We kind of expected the, when we flip a coin, 50-50 chance for it to be heads or tails. And so we expect to get 50% heads, 50% tails. For our standard deviation, we're going to go little subscript there for p hat. You go to the right to get out of that subscript. our standard deviation there. I found out that you can do square roots in here. How fun. So we just got to go that little square root x there. Got to make sure we're in there before we do square root of x. And we went inside there, n times p times 1 minus p. That's from our last class. And now what we're doing with that is we're dividing by n. So what we can do is we can bring this inside the square root. Because if we have, let's jot this down, a little algebra here. If we have n, that'll be the same as the square root of n squared. So I can bring this n inside. Let me get back to my equation editor here. So I want to copy that whole top there. And so what we're going to do is we're going to divide this whole thing by n squared. And then hopefully we can see what will happen from that. I need an exponent. There we go, n squared. And so since I have this n on top, let me get my little drawing tool, this n on top and n squared on the bottom there, and n will cancel. So this n cancels with one of the two n's there, and I'm just left with what's left over there. So I'm left with the square root of p times 1 minus p divided by n. So I know that's not the cleanest thing because of the Statsmatic logo there, but we're going to rewrite it on the next page as well. And again, we just canceled out that n, so it's p times 1 minus p over n, all the square root of that. That's how we get our standard deviation. And before I forget, let's make sure that we know that these are p hats. And we're going to, again, write this down on the box on the next page as well. So whereas we had sample counts on our previous page, where we had our sample counts, let me highlight where that is for you on here, where we were looking at the sample counts, a sampling distribution of a sample count. Today we talked about sampling distribution, how it doesn't really change the look of it, just the values that we have there. So we're not really manipulating, we're not changing the data, we're just manipulating it to make it a proportion instead. And because of that manipulation dividing by that n, our formulas will change a little bit too. So one gets a little easier, one gets a little tougher. But again, we can make sure Statplet or our calculator does all the work for us. So some important ideas is going to be those formulas. So first we want our formulas here for mean and standard deviation. And I'm going to go to my equation editor here. And honestly, I'm just going to go copy what I have here. Can I duplicate it? Never mind. Can't duplicate it. So we're going to type my mean formula here. So I want mean sub with a p there. That didn't work at all. Mean and subscript p, and that should equal p. And so these are different p's. So the p that is the subscript, that is our sample proportion. So we got to make sure we have the little hat on that so that we know that that is our sample proportion. And then p is going to be the given proportion, the one where you like expect to be true, the population proportion. That is, 50% for flipping a coin. And we'll jot all that down in a second too. Our equations, let's get an equation over there. We want sigma subscript p hat equals, and we want a square root. So we're going to rewrite what was kind of hidden over here. Square root of p times 1 minus p divided by n. So let's put that where we can see it nice and easily right there. And again, we want to make sure our p is a p hat for our sample proportion. You go away. P hat there. What's happening, man? So we can jot down some little things here. So p is our population proportion. N is our number of trials, and then p hat is going to be our sample proportion. So a couple more notes here that just going over similar stuff to what we did last class is we have our large counts. Let me just jot down here. Large counts. We saw quickly that we have if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10, then the sampling distribution of p hat is approximately normal. And we were able to see that today because we did it last time too. Let's make sure we can see all that right there. Get this little underlined. And then we want to just sketch our normal graph, because from this we can also go and find probability using our normal distribution and our z-scores in table A. So we're going to draw a little baseline here. I'm going to try and sketch a normal distribution curve. Oh, beautiful. And then right in the middle, we'll have our p. And then either above or below, we'll have our p hat. While I got the drawing tool, we're going to make those equal. And then p hat is p hat as well. And then if we want to shade below or above, whatever we're discussing there, this is a normal distribution with our mean of p hat. Good, we have that down there. And our standard deviation of p hat. And to find our z-score, we're going to take our sample proportion p hat minus the population proportion and divide by the standard deviation of our sample proportion. We can use table A. The last video also went into depth about how to use Staplet to analyze normal distributions as well, and hopefully we'll do that again in class. All right, any questions, ask your teacher. We're going to go over application 6.4 on the bottom of this in class. Take care.